Okay, in this tutorial we're going to be looking at constant acceleration. Now, for all those students out there that are studying physics as well, this should be pretty straightforward. So we have 5 equations of motion. Now these equations of motion only work if we have, as the name suggests, constant acceleration. Okay, so our equations of motion are v equals u plus at, s equals ut plus a half at squared, v squared equals u squared plus 2as, s equals a half outside of u plus v times t, and s equals vt minus a half at squared. Now, v is our final velocity of our object, u is our initial velocity, okay, both in meters per second. Acceleration is a, and that's in meters per second squared. Time is t, and that's in seconds, and s is for displacement, and that's in meters. Okay, now these rules here, our equations, only apply when acceleration is constant. Okay? V, U, A and S are all vectors, so direction matters. Okay? Our displacement is not the same as distance. Okay? So our displacement is how far an object has moved from the starting point regardless of the path taken. So for example, okay, if I'm starting here, okay, and I go over there, okay, following this line would give my distance. My displacement is that, okay, directly straight line as the crow flies, if you like, as the saying goes. Okay, straight line. Now also, to convert our kilometres to convert kilometres an hour to metres per second, we need to divide by 3.6, and to convert metres per second to kilometres per hour, we times by 3.6. Okay, we'll flip over and have a look at a worked example. Okay, now what's really important here with worked examples is to list the important information that you know, or just what you know, what you don't know. Okay, because basically each one of the equations, I'll flip back for a second, is missing one of these variables. So each one is missing one of them. Okay, so we've got 5 variables, each equation will miss one of them, okay, and you'll need to be finding another. So you need to list down, I'd always just write these down, okay, and go which ones do I know, write down their values, which ones don't I know, okay, and which one am I trying to find. Okay, so we'll have a look at the first worked example. So we have a tram uniformly accelerates from a velocity of 10 metres a second to a velocity of 15 metres per second in a time of 20 seconds. Okay, find the distance travelled by the tram. Okay, so we're going to write down what we know. Okay, so now about V, U, A, T and S. Okay, V is our final velocity. So we know that our final velocity is 15 metres per second. Okay, our initial velocity was 10 metres per second. A, we don't know. T, we know is 20 seconds. Okay, and we want to find the distance travelled, or our displacement. Okay, so that's what we want. We don't have A. So we flip back and go, well, which equation doesn't have A in it? Okay, and it's going to be this one here, with our S equals a half outside of U plus VT. So I'm going to use S equals a half U plus VT. Okay, and that's going to give us our displacement. Okay, so all we need to do is sub in our values. S equals a half outside of U was 10. Okay, plus V is 15. Now these are both in the same direction. Okay, so we don't have to worry there. Okay, it's only if we were going in one direction, then we, for some reason, turn around and we're going back, that we'd have to worry. And our time is 20. So I think we've got 10 times 25. Okay, we're going to go 250 metres. Okay, so the distance travelled is 250 metres. Okay, so often you can see, even though we talk distance, we used our displacement one. That just means that we're assuming that we're going in a straight line. We haven't gone around a corner or anything like that. Okay, we've got another worked example. So a triathlete on a bicycle reduces her speed from 10 metres a second to 4 metres per second over 28 metres. Assuming the deceleration is constant, determine the deceleration and how long the triathlete will travel on her bicycle before she comes to rest. Okay, so what we need to do is look at what we have again. Here's our V, our U, our A, our T and our S. Okay, we know that our V is 4 meters per second and that our U is 10 meters per second. Okay, and note, they've been nice, they haven't given us any units that aren't in the ones that we want. Okay, we don't know A, but we know S is 28 seconds. Okay, and we want, assuming the deceleration is constant, determine the deceleration, okay, and how long the triathlete will travel. Okay, so we want both of these things. Okay, so I'll start off, okay, looking at, well, finding, let's say, our A to start off with. Okay, so we look back, which equation doesn't include T? So you look, which one doesn't include T? Here we go, V squared equals U squared plus 2AS. So V squared equals U squared plus 2AS. Okay, so for V we know we've got 4. Our U is 10 plus 2 AS. Okay, and our S was 28. And so we've got 16 equals 100 plus our 56. Okay, and so when we rearrange that, 56A, when we rearrange that we get A equals minus 1.5. Now we expect minus because we started at 10 and went to 4, so we'd expect that our acceleration is going to be negative. That's meters per second squared. Okay, now we look and go, okay, well we need to find our T value. Now you could use this acceleration value, okay, and they do actually do that, but what's actually better is to not use the value that we just found because there's a chance that we got this wrong. Okay, so you look and go, okay, well I don't know, I want the equation without A this time. Well, without A is this one. So we want to use our S equals a half outside of U plus V T. Okay, this is, as I said, this is a better one because it doesn't use our A value. Okay, and we want to find how long the triathlete will travel for, so we want to find our T. So we know our S is 28. So a half U, which is 10 plus 4 times T, so we've got 28 equals a half times 14T, or 28 equals 7T. So T will give us 4 seconds. Okay. And that's it for this worked example. Okay, and that's actually it for all our worked examples for this section. It's a bit of a small section, so hopefully you won't have too much trouble getting through it.